So we've just been working a little bit with an introduction to the section. Sorry, just pressed record now, but we have plenty of examples coming your way. I'm going to be annotating directly on your workbook page. And you can see that the workbook is sort of guiding you through rewriting the division problem as a multiplication problem. So if you want to look right here at number 1, notice how the division problem is written first. And then right here, we're rewriting it as a multiplication problem. So remember, we're keeping the dividend as it is. We're changing the division symbol into a multiplication symbol. And then we're changing the divisor to be the reciprocal of the fraction that it was. So everyone on this first one, just please go ahead and write 4/7 times 3/2. And what would that end up being? 12/14. Reduce it, please. 6/7. Is that too far away? Should I zoom in? We okay? All right, let me see if I can zoom in a tiny bit more. Come on. Get out of the way. That better? Yeah. What's all the giggling going on? That's like a fuzzy on my head or something? We good? Anyone need to take a little walk break in the hall?
I was walking outside.
I didn't. You're going to miss stuff, so I wouldn't take it unless you really need it. But how would we rewrite number 2 as a multiplication sentence? So 3/4 divided by 3/16 is really the same as 3/4 times, what's the reciprocal? Go ahead. 16/3. Now, you can snap across if you want. 3 times 16 is 48, 4 times 3, 12. But then you'd have to simplify. If you're able, practice the skill of cutting down on the factors where you can, when you can. 3s and 3s cancel each other out, right? So what would the total product here be? It'd be 4 divided by 1, which is just plain old 4. Okay. How about number 3? Let's rewrite it as a multiplication expression. 7/12 times, what's the reciprocal? 9/7. Any opportunity for reducing beforehand? Yep, let's get rid of the 7s. Let's take out a factor of 3 between the 12 and the 9. If I took out a factor of 3 from the 9, what would be left over? 3. And if I took out a factor of 3 from the 12, what would be left? 4. Good. So then the resulting fraction is 3/4. All set? All right. Let's rewrite the next one. 8/15 times, what's the reciprocal? Nice. Oh, these can definitely be reduced beforehand. Let's cut down between the 8 and the 16. That leaves a factor of 1 and 2. Between the 25 and the 15, that leaves a factor of 5 and 3. So when you snap across now, what are you left with? 5, 6. And the difference between the numerator and denominator is 1. So you're done. 1 and done. I'd like you to tackle on your own right now, number 5 and 6. Okay, you're writing number 5 and 6 right now in your workbook.
I don't have my workbook with me, so what do I use?
Paige, I don't know what you have with you, honey. You're going to have to make that decision on what you can do to participate in your class right now. Do you have loose leaf? Do you have something to write with? I'm not sure what I can do for you from this perspective here. You figure out how you can participate in the lesson so you know the content, okay? All right. How did you rewrite number 5? How did you keep, change it? We keep 4/15. We changed the division symbol to a multiplication one. And then what'd you change the divisor to be? 5/1 or 5/1, as someone just said. 5/1. 5/1. 5. Let's cut down the factors here of 5. So we're leaving 3 and 1 over here. And that's 4/3. Hey, improper fraction alert, right? So you can't leave it like that. How do I convert it to mixed number in simplest form here? I would say 4 is divided by 3. How many whole times? 1 whole time with 1/3 left over. How'd you do on that one? 1 and 1/3. All right, number 6. Well done. Keep, change it here. So 1/8 times 7/1 equal 7/1. You just say first. 7/8. 1 and done, right? Not too bad, is this? Are you good? Yes. Okay. So, Erin, do you understand this little catchphrase that we're saying, keep, change, how it relates to the fraction kind of equation, or do you want me to show you that part again? Okay. So we're going to clear this out and we'll do number 7. Let me scroll on down. If you're feeling confident and comfortable, go and finish 129. Finish 129. And then every now and then, I want your eyes to come up and look and check yourself. But don't go on to the homework until we have an understanding of your content is in the right place right here. Okay. So, Erin, the idea of keep, change means that when you convert a division expression into a multiplication one, because they're complementary operations, this trick works where you can keep the first fraction as it is. You change the division problem to a multiplication one, and you change that divisor to its reciprocal, which is the exact opposite. Multiplication and division are exact opposites of each other, right? So we're using that to our advantage and keep, changing a division expression into a multiplication one, because we know the multiplication procedure is so easy. We just go straight across, right? So when I rewrite this division problem, this one is staying the same. That's the keep, right? See how he stayed the same? Then we're going to change the division into multiplication, right? So that's another change. And then we're going to change the 4/9 into its reciprocal, which is the exact opposite of itself, 9/4. So we're going to keep and then change. So when I do snap across, I mean, I could look for places to kind of trim down the factors, right? But could you just snap across and simplify afterwards? Yeah, you could. You're going to end up with bigger numbers, which may or may not worry you. But if you snap across and get 45/48, you would recognize they both have a factor of 3 inside. So if you cut down on the factor of 3, you would be left with 15/16 for this one. Okay? Help me keep, change the next one, okay? Keep, change. And we change this one. What are we changing it to? What's the reciprocal? What are we changing it to? 25/14. Yes. Okay, so now we're not even looking at this part anymore, right? We don't care that it used to be a division problem because we're using an equivalent and equal expression to get our answer faster. Now, dividing will work. It just is more difficult because you're getting fractions of pieces instead of whole numbers to work with. So here, let's just do the multiplication method. Do you see any shared factors between 7, 14, 25, 15? Do you see any shared factors there? Anyone at home? Anyone see shared factors between the numerator and the denominator?
7 and 14.
They share a factor of 7. So I'm going to go and remove it, leaving 1 and 2. Good. Do 25 and 15 share any factors? They sure do. They share a 5, right? So I can get rid of it, leaving a 5 and a 3. Now, if I snap across now, I have 5, 6, which I know is done because the difference between the numerator and denominator is 1. How are we feeling about this? It's the exact opposite of multiplication. How'd you do on number 9? How'd you do on number 10? Notice they stopped rewriting it for you. Now you have to rewrite it. Keep, change, change. I'm going to cancel the 5s. What do 24 and 6 have in common? Anything? A 6, sure. So we get rid of that. We're left with just 4 over 1, which is equal to 4. So what this means is if you had a quantity that was equal to the length 5, 6, and you divided it into sections of valued 5/24, you would have 4 sections. That's what the equation really means. Now we're going to get into modeling tomorrow. Definitely not with expressions this intricate, but I do want you to conceptualize, what does division with fractions, what does it mean? What does it look like on paper with a model? This one is definitely one we could expect to do a model of tomorrow, and I'll show you why. Let's rewrite it as a multiplication expression. So keep, change, change. Anything I can kind of slim down here on between the numerator and denominator? Looks like the 16 and the 4, right? Leaving a 4 in the numerator and a 1 in the denominator, leaving us 12 over 1, which is equal to 12. Okay, so just, I guess, as a preview of tomorrow, let me show you what this one would look like as a model drawn. You can draw 3/4, right? This is 3/4. How would I divide 3/4 into sections that were valued at 16ths? So right now they're just in fourths. How could I change them to be 16ths, Isaac? How could I change them? So he said, slice it into 16 equal parts by going across the shape horizontally. Do I have 16 equal parts now? How many are shaded? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hey, wasn't that my answer?
I love how you took the time to draw stars in every box.
You're welcome. I'll go the extra mile for you. But do you see how the answer is shown on that model? That if you take the value and the shape of what 3/4 looks like and slice it into pieces that are 1/16 big, how many pieces do you end up having? 12. We'll work more on modeling tomorrow or Wednesday, whenever I have you next for math. All right, last one here. Let's rewrite. I'm going to get some of this out of the way so I have some space. Okay. We know this one was 4. We know this one was 12. If you're catching up, let's rewrite this one as a multiplication expression, okay? Keep, change, change. Anything to trim down on? Yeah, John, go ahead.
4 and 16 to the 4 and 1 and the 16 is okay.
He said get rid of the factor of 4 between these two guys. Get rid of the factor of 5 between these two. So by doing that, what you're taking away is the work on the backside of reducing. You will not have to reduce anymore if you properly, simplified beforehand. Yeah, on our homework, which is the next page, you'll see that numbers 1 through 9 are standard procedural. I'd like you to not just write the answer. Can you please rewrite each problem to be a multiplication problem? I mean, that's what you have to do anyway to solve it, right? Here's what I mean. Let me scoot down and show you that part of the page. Okay.
Can we do like the dot instead of like the times symbol?
Yeah. So on the instructions, I'm actually going to type, rewrite each expression to be a multiplication expression and then solve it. Does that make sense? I want you to please rewrite each of those expressions as a keep, change, change, and then go ahead and solve it. So for instance, number 1, I would expect that like right underneath it, you would go keep, change, change, and then solve it. Does that make sense? Do you know what I'm asking of you?
So like what we did on the.
What we did on our guided practice. Rewrite it, then solve it. Simplify wherever you're comfortable, before or after. But do not leave any improper fractions. Do not leave any fractions that aren't in lowest terms. Reduce it all. Simplify it all. And I'm comfortable with you doing all of the problems on 130. I think they're manageable. Okay. So you have some time here for question answers. But preview the page and see if there's anything you want my help on before we dismiss class, okay? Preview the rest of the page.
So we don't have you tomorrow? No, because
I have the online kids tomorrow, and I have you guys Wednesday, and I don't have them Wednesday. So this is technically due Wednesday for you in-person people, okay? But you have Freckle too, so I'm hoping that you can take care of that. All right, I'm here if you need me. I'm gonna pause this recording though. Let me know if you need anything. We have about 5 minutes left of class here, okay?